Hello, and welcome to week number 16. Let's get going. Last week we were talking about taking integrals when we were talking about separating them, so separation of variables here. So if I was going to work on this problem, the first thing I'm going to do is I'm going to rewrite this as 2x, 2x plus 3 over x minus 3, x plus 3. And then I'm going to rewrite this as a over x minus 3 plus b over x plus 3 is equal to 2x plus 3. I'm going to cross multiply. So this gives me a x plus 3 plus b x minus 3 is equal to 2x plus 3. And then I'm going to multiply through. So I get ax plus 3a plus bx minus 3b. I'm going to put my x's together. So I have ax plus bx plus 3a minus 3b is equal to 2x plus 3. I'm going to factor out an x here. So I have a plus b plus 3a minus 3b is equal to 2x plus 3. But now I know in front of the x term that's a plus b, so I know that's 2. So I know that a plus b is equal to 2. And I also know that 3a minus 3b is equal to 3. And using the addition method to solve a system of equations, I'm going to use a different color so I can see what I'm doing here. I'm going to multiply everything by 3 here. So that's 3a plus 3b is equal to 6. If I add straight down now, I get 6a. The b's cross off. It's equal to, is that 9? Oh, that does not make this nice. All right, so a is equal to, what is that going to be? 3/2. And if a is equal to 3/2, I know that a plus b is equal to 2, so b must equal 1/2, right? So now I can plug this back in. So this becomes 3/2 here. This becomes 1/2 here. And now I can take the integral of each of these. So I'm going to end up with 3/2 natural log of x minus 3 plus 1/2 natural log of x plus 3. That's what we worked on the week before vacation, taking the integrals of that. Today, we're going to be working on improper integrals and slope fields. I'm not going to spend a lot of time on slope fields because you should have had slope fields last year. Improper integrals, no. But slope fields, yeah. Slope fields are pretty easy. Improper integrals. An improper integral is an integral where you're going to be finding an integral of something that looks like it goes on forever. For example, if you looked at the graph y is equal to e to the negative x over 2, you'd see that this graph comes down and it goes on forever. And we would think that, you'd think that the slope or the area just keeps increasing and increasing because it just keeps going on and on and on. But that is not the case in most of the times. So what we're going to do is we're going to find the integral from, let's say we're finding the integral from 0 to infinity. Okay? So what we're going to do is we're going to break this up. We're going to say, oh, okay, we're going to find the integral from 0 to b, plus we're going to find the integral from b to infinity, and we're going to add those together. And we should come up with a solution. Now, sometimes it will be infinity. The area is just going to keep growing and growing, but not all the time. So this is basically how we would do that problem, and we haven't learned how to do it yet, but this is the steps that we're going to be taking. And we're going to have to use some of the rules that we learned last week or a couple weeks ago about taking integrals also. But here are the rules here. It says If we're going to find improper integrals with indefinite integrals, they're indefinite, that means you're going to go to infinity here. What we're going to do is we're going to break it down. So we've got the integral from a to infinity. We're going to break that down. We're going to say it's going to be from a to b, and b goes, the limit as b goes to infinity. And if f of x is continuous from negative infinity to b, then we're going to go from negative infinity to b, the limit as a approaches negative infinity. We just have a to b. So let's take a look at an example. Okay. Here are all the improper integrals. You can have negative infinity to, so if you have like 3 to infinity, we're just going to do the limit as b approaches infinity as a goes to b. If we have negative infinity to b, then we just have the limit as a goes to negative infinity from a to b. And if it's continuous from negative infinity to infinity, then we break it into two separate problems. We go from negative infinity to c, and then c to infinity, and we just add those together. So let's take an example. Okay, let's. I think this one goes. I want to say that this one starts at 1. I'm not 100% sure. I think it was 1. So let's go from 1 to infinity of x e to the x, and let's try to find the integral there. Okay. So if I was going to do this, the first thing I have to do is I want to find the integral of this thing, and that goes back to finding the integrals. So I'm going to go f of x is x, derivative of x is 1, derivative of 1 is 0, and then remember we take the integral of e to the negative x. Well, that's e to the negative x, e to the negative x over negative 1, which just gives me negative 1 here. And then if I do it again, it's just going to give me a positive 1. So then if I take the integral here, remember this is a plus and a minus. So that's going to give me the integral is going to be, oh, I shouldn't put that in there because we're taking the integral already. So that's going to be x, negative 1 in front. So negative 1 x e to the negative x minus, then it's going to, so this is going to be minus e to negative x. Now, when I rewrite this thing, I'm going to go from 1 to infinity, but I'm really going to say the limit as b goes to infinity of integral of 1 to b x e to negative x. Well, I've just taken the integral of this, and I came up with this. So this is going to be negative x e to the negative x minus e to the negative x from 1 to b. Remember, this is the limit as b approaches infinity. And so I'm going to plug b in here. So that gives me negative b, e to negative b minus e to negative b minus, okay, I'm just plugging the b in, then I'm plugging the 1 in here. That's negative 1 e to negative 1 minus e to negative 1. Then if I plug infinity, because this is the limit as b approaches infinity, so I put infinity in here, you're going to see that this becomes 0 minus, well, this is going to be negative 1 over e minus 1 over e. So that's going to be negative 2, oops, negative 2 over e. But that has a minus sign in front, so that should be a positive. So positive 2e, 2 over e. All right. Here is a little bit better worked out. Now, you'll see that they did not use the same method that I used for finding the integral. They used the old-fashioned method, and I showed you the quicker way of doing it using the diagonals. But you get the same answer. I mean, all you really have to do is be able to get the integral. I mean, that was the kicker, is being able to get the integral. Right? And we already know how to find the integral. So then we're just finding the limit as that goes to infinity. All right. Now we have one that says we have an integral from negative infinity to infinity of e to the x d of x in terms of limits. So we want to find the limit here. So first thing I'm going to do is I'm going to just break it up. I'm going to break it into a couple problems. I'm going to do the limit as b approaches negative infinity of the integral from b to 0. Now, I don't have to go to 0. I could go to 10 or 20 or 30. It really doesn't make any difference. 0 just, to me, makes sense. E to the x plus, and then I want to do the limit as b goes to infinity of 0 to b. And again, I could have put a 10 here, and I could have put a 10 here. It makes no difference at all of e to the x. So now I'm going to work on each part separately. So I take the integral of e to the x. Well, the integral of e to the x is e to the x from b to 0. And that is still the limit as b approaches negative infinity. Well, if I put 0 in there, I get e to the 0 minus e to the b. And that is the limit as b approaches negative infinity. Well, e to the 0 is 1. And then e to the negative infinity, well, isn't that 1 over e to the infinity? Which that is 0, isn't it? If my math skills are correct. So this just becomes 1. Now, if I do the same thing over here, again, I've got the integral, e to the x. That's the integral of it. And I'm going from 0 to b. So if I put b in there, I get e to the b minus e to the 0. E to the 0 is 1 again. E to the b, now that I'm putting infinity in there, the limit as b goes to infinity, well, you put infinity in here, e to the infinity is infinity. Doesn't matter what we're adding, so we had 1 plus infinity. That doesn't make any difference. This is divergent. We call it divergent because it doesn't diverge onto a number. It's infinity. So this one, the area you can't really compute because it just keeps going on and on forever, right? So sometimes the area is divergent. Now sometimes you're going to get integrals where you have a vertical tangent someplace, and so you're going to have to come from both sides to figure out the answer. Okay, for example, if I had the integral from 0 to 3 of x minus 1 over 2/3, well, you know there's something happening at 1 because it's going to make it 0 in the denominator. So what we're going to have to do is we're going to have to break this thing up. We're going to have to break it up into an integral from 0 to 1 plus the integral from 1 to 3. I'm going to have to solve both of those. And what you're going to have is, you know that when you're coming from 1, from 0 to 1, we're going to have to take, the limit is going to be going to 1 there. So let's take a look at the work here. So what we're going to do is we're going to find the limit as c goes to 1 from the left-hand side. So we take our integral. Our integral is 3x minus 1 to the 1/3. And we're going to plug in c. So we end up with 3c minus 1 to the 1/3 plus. And if we put 0 in here, we end up with 3. So the limit is going to be 3 when we're going from 0 to c. But now we also have to do from c to 3 because there was a vertical tangent there. So we also have to find. So we do the same thing. Take the integral. 3x minus 1 from c to 3, but now the limit is as we approach 1 from the right-hand side. And if you plug 1 in there, you get 3 to the third root of 2. So we just add these two together, our 3 and our 3 third root of 2, and we get the area underneath that curve. Now this week we were talking about slope fields, and slope fields are pretty easy. Slope fields deal with finding the slope at, slope field gives you the slope at any given point on a graph. So let's just take an example. Here's a problem that probably had last year. It says, consider the differential equation dy dx, y minus 1 over x squared. It's kind of hard to read, so I'll do this. Dy dx equals y minus 1 over x squared. And it says on the axis provided, sketch a slope field for the given differential equations. So when they give you something like this, they'll tell you the points that they want you to use. So they want us to use this point right here, which is 1, 0. And then they want us to use this point here, which is 1, 1. And they want us to use this point here, which is 1, 2. But we have to find the slope at each of those points. Well, 1, 0. So if I put 0 in for y, I end up with negative 1 over 1 squared, which is just 1. So the slope there is negative 1. So I put a little slope of negative 1 there. And here I got 1, 1. So if you put 1 in for y, so we're going to end up with 0 over 1, which is 0. So my slope would be 0 here. If I put 1, 2 in here, 2 minus 1 is 1. So that's a slope of 1. So that's how you find slope fields. You just keep finding the slope of each thing. And then sometimes they'll ask you some questions. For example, it says, find the particular solution to the differential equation with the initial condition f of 2 is equal to 0. I believe that's what we're going to work on next week, finding the initial condition of functions. So you don't have to work on this one. Now, they could ask you to write an equation of a tangent line. You should be able to do that because you can find the slope and if they give you a point. And I do think they do ask some questions like that on this week's assessment, but the the initial condition type problems, that's what we're going to work on next week. All right, that was pretty quick. I think that was the last slide. Oh, that was my slope field there. All right, you guys have a great week. Bye.